Hi, welcome back to Mrs. Thompson's classroom. Today we're going to be talking about polar coordinates, and this is the beginning of our unit on this topic. So we're going to start with just the basics of what the polar coordinate grid looks like and how we plot points. So the polar coordinate system is based on these concentric circles, and so every point is based on the radius, the distance from the center, okay, which we'll call the pole, and then the angle from the x-axis, or in this case called the polar axis. So to graph a point, let's just start with 260 degrees. So what we'll do is we'll go out 2 on that polar axis, and then we're going to go around 60 degrees, okay, and then we plot our point, okay. To graph for negative 45 degrees, we will go out 4. Now we're going to go negative 45 degrees, so that'll be going down, in other words, clockwise 45 degrees, and I plot my point. Okay, we could do 1,120 degrees, so I'll go 1, and then I go around to 120, which is also 2 pi thirds, and I plot my point. Okay, so this is just plotting points. Right? Now we can also, of course, do these in radians, which you can see the grid I've got there is marked in radians. Now what happens if our r is negative? Well, r is a distance, right? And so it's the distance from the pole. And so truthfully, the point r theta lies the absolute value of r units from the pole. So if r is negative, it just implies that we're going in the opposite direction. Okay, so instead of going, 45 degrees into quadrant 1, we'll go over into quadrant 3, that equivalent angle. So let's take a look at these. So to do negative 250, so the first thing I'll do is I'll go to 50 degrees. But then I'm going to go exactly opposite from that, so 180 degrees from that, and plot my point, okay? Now, one thing you can do is notice that means we're adding 180 degrees to that angle, so I could rewrite that point with a positive r value, but with the 230 degree angle, okay? All right, let's do another one. This one we're going to do in radians, so I'm going to go 2 pi thirds, negative 4. So we're going to go 4. We're going to go to 2 pi thirds. We're going to go exactly opposite from that and then plot my point. The other thing you can do there is instead of adding 180, we'll add pi. And so we get 4, 5 pi thirds. And you can see on the grid there, that's exactly where we ended up, was at 5 pi thirds. Okay. Let's do one more. So negative 1, 11 pi 6. So 11 pi 6 is actually down here in quadrant 4. So I'll go 1, and then I'll go to the 11 pi 6. Notice I can just go clockwise there since I know where that angle is. But then to go a negative 1, I'm going to go exactly opposite of that. And so where we end up with is 11 pi 6 plus pi, or 11 pi 6 minus pi, so we end up at 1 5 pi 6. Okay, so r just means we're going in exactly the opposite direction. So that also brings us to the fact that each point, since we're talking about circles and angles, each point can be rewritten a variety of ways. So so here we can write them in equivalent ways. So we have 3 pi fourths. So one thing I can do is simply get a coterminal angle by adding 2 pi. Okay, so pi fourths plus 2 pi, that would be adding 8 pi fourths. So I get 9 pi fourths. The other thing we can do is subtract 2 pi. Or we can even make the r negative and add pi. Okay, and all of those would be equivalent points. So let's do that one again. On B, I start out with a negative angle, and I can add 2 pi, which would be 12 sixths. So I get 19 pi 6. or I can subtract 2 pi, so 7/6 minus 12/6 would give me -5. Or I can take my r and make it a +5, and then I just add pi. Okay. So you might want to pause the video, see if you can try option C here. All right, so if you've tried that one, so again, we can find the coterminal angle. Now that we're in degrees, we're going to add 360, or we could subtract 360, or we can take the r value and make it a +2 and add 180 degrees. Okay, we could subtract 180 degrees too. So there are actually an infinite number of options for our answers here. Okay, so hopefully that just gives you a little idea of what the polar coordinate system means, just how do we plot points. Next time we'll talk about actually converting between polar coordinates and our normal Cartesian coordinates, how we change r and theta back to x and y and vice versa. And then eventually we're going to start graphing some fun graphs in these. In polar coordinates, we get to graph flowers and infinity symbols, which are actually called lemniscates, and we're going to graph spirals and even some things that look sort of like hearts. They're called cardioids. And so we're going to have a little fun with that. And so hopefully you'll join me next time as we continue our unit on polar coordinates.